Even if you take this trajectory and just arrange for a random arrival time, you get 1 in 20,000 chance of it coming as close as it does to Jupiter, Mars, and Venus.
The shock hits instantly. When the XMM Newton data stream locks in, scientists freeze, not in awe, but in alarm. This is not the soft glow of a cold, drifting comet. What fills their screens is an active eruption of energy, sharp and aggressive, cutting through space in wavelengths never meant for a simple ball of ice. The signal is unmistakable. X-rays are pouring from 3I Atlas. This should not be happening. X-rays do not come from reflected sunlight. They do not come from passive evaporation. They are born only when matter is ripped apart, accelerated, and slammed into charged forces at extreme speed. And that is exactly what the data shows. Gas is being torn violently from the comet's surface and hurled into the solar wind, colliding with streams of charged particles racing outward from the sun at hundreds of kilometers per second. The result is ignition. Invisible forces suddenly become visible. The comet lights up like a wound in space, its red-tinted X-ray glow bleeding into the blackness. This is not decay, this is reaction. A chemical and electrical clash unfolding right now, in real time, as alien material meets the sun's magnetic domain. Researchers immediately recognize the danger in what they're seeing. X-rays mean charged interactions. This is the physics of stellar flares, superheated plasmas, and explosive environments, not comets. Yet here it is, happening around an object that was supposed to be quiet, fragile, and predictable. 3I Atlas is not dormant. The X-ray emission reveals something optical telescopes never could. This object is chemically active under stress. Its surface is not gently warming. It is being stripped, ionized, and forced into violent exchange. Every second, foreign atoms forged around another star are being torn apart and rewritten by our sun. For the first time in human history, an interstellar comet is caught exposing its internal physics as it breaks down. Not through dust or light, but through energy. And that is what unsettles scientists the most. If this level of interaction is already happening at this distance, if the comet is producing X-rays now, then something far more intense may be waiting ahead. Because 3I Atlas is still moving inward. And the sun's influence is only getting stronger. And just beyond this first ignition zone lies something even more alarming, the invisible battlefield where the solar wind itself begins to fight back. The danger appears the moment 3I Atlas crosses an invisible boundary near the sun. Instruments detect a sudden surge of charged particles racing toward the comet at hundreds of kilometers per second. What follows is not gentle heating or slow evaporation. It is impact. The gases erupting from the comet's surface slam head-on into the solar wind like microscopic bullets, each collision releasing bursts of energy. Scientists did not expect to see this early. X-ray data lights up almost instantly, outlining a violent collision zone wrapped tightly around the comet. This glow is not decoration. It is a shock front, a boundary where alien material is being ripped apart, ion by ion. The battlefield stretches far beyond the visible coma, revealing an interaction region much larger than optical telescopes ever suggested. The comet's influence extends outward like a pressure wave, reshaping the space around it. Researchers quickly realize this is not how solar system comets behave. The structure refuses to stabilize. The plasma twists, flares, and reforms as if the chemistry itself is fighting back. Models begin to fail. The energy exchange points to unfamiliar molecular reactions triggered by solar radiation, reactions never tested on objects born around another star. This is no ordinary tail drifting quietly away. It is a living plasma system, constantly reshaped by impact and charge. The sun is not just illuminating the comet, it is stripping it, electrifying it, and forcing it to reveal properties forged in a completely foreign stellar environment. Every second, more material is torn free and thrown into violent contact with solar defenses. The realization spreads through the data teams. This is the first time scientists are watching truly alien matter collide directly with the sun's particle shield. And if this level of disruption is happening now, far from the sun's surface, the next phase could be far worse, because something else begins to appear in the X-ray data, something the models were never designed to explain. The shock does not come from what scientists expected to see, it comes from what suddenly appears where nothing should have been. As the XMM Newton X-ray data resolves, researchers realize that optical and ultraviolet telescopes completely missed a critical truth. The comet is surrounded by gases that refuse to show themselves in visible light. Hydrogen and nitrogen erupt across the X-ray frame, glowing under stress, exposed only because they are violently colliding with the solar wind. This is not a small correction. This is a fundamental failure of every earlier model built around the object. Hydrogen dominates the signal, flooding the data with signs of extreme volatility. Scientists immediately understand the danger of that word. Hydrogen does not linger unless conditions are severe, cold, and chemically unstable. It escapes easily. It reacts quickly. Its presence in such quantity means the comet's internal structure is far more fragile and far more reactive than previously assumed. This is material that should not survive long near a star, yet here it is, actively engaging with the sun instead of fading away. Then comes the nitrogen signal, and the room goes quiet. Nitrogen does not belong here in these proportions. Its presence points to an origin colder than the Kuiper belt, older than most objects ever studied, forged in a region of space Earth never experienced during its formation. Nitrogen-rich chemistry suggests a birth environment where temperatures dropped to extremes and stayed there for millions of years. This is not recycled solar system debris. This is preserved alien material now being torn open in real time. As the data layers stack, scientists realize the most unsettling truth. Earlier observations were incomplete by design, not by error. The comet was hiding its true makeup in plain sight, invisible to every telescope that relied on reflected sunlight. Only X-rays produced through violent particle collisions could force these gases into view. The comet was not quiet. It was chemically active, but only under stress. Only when it was pushed by the sun did it reveal what it really carried. The implications spread fast. If hydrogen and nitrogen make up this much of the comet, then its density, mass, and stability estimates are all wrong. Its behavior near the sun can no longer be predicted using standard comet physics. Models begin to break apart. Volatility this high means sudden outbursts are possible. Fragmentation becomes a real concern. Every assumption about how the comet will react as it travels deeper into the solar system is now under question. The realization lands hard. This object was formed under conditions Earth has never known and may never encounter again. Its chemistry is not just unfamiliar, it is ancient, extreme, and reactive in ways scientists are only beginning to understand. This is the first time gases from another star system have been directly observed colliding with our sun at this level of detail. Not inferred, not modeled, seen. And that is what makes the fear settle in. If these invisible gases were only revealed because the comet was pushed into a violent interaction zone, then something else may still be hidden. Something that has not yet been forced into the light. As researchers lock on to the next data pass, one question dominates every discussion. If this is what the X-rays revealed under pressure, What will appear when the comet is pushed even harder next? It is already slipping away. 3I Atlas is not slowing, not looping back, not offering a second chance. Its path is locked, an escape trajectory that will sling it out of the solar system forever. Every calculation confirms the same brutal truth. This interstellar object is a one-time visitor. What scientists fail to capture now will be lost not for years, but for generations. Inside control rooms, the pressure spikes. The 20-hour XMM Newton observation window becomes a race against physics itself. This is not a follow-up session. This is the session. The telescope stares as long as orbital mechanics allow, while engineers fight background noise, solar interference, and shrinking angles. Every minute that passes slightly degrades the data. Every hour, the comet moves farther from ideal alignment. At 285 million kilometers away, 3I Atlas is already retreating from the sun's most revealing vantage point. Its X-ray signal weakens unevenly, not smoothly fading, but fluctuating in bursts, as if the comet is changing behavior mid-escape. That alone unsettles researchers. Comets are supposed to quiet down as they move away. This one doesn't follow that rule. Teams scramble to cross-link observations in real time. X-ray readings are rushed into comparison with infrared heat signatures and ultraviolet emission lines. The goal is brutal and simple. Extract the full chemical and physical profile before the signal collapses. Hydrogen spikes appear where models predicted decline. Nitrogen traces linger longer than expected. Something about the comet's internal structure is resisting rapid shutdown. Time becomes the enemy. There is no pause button in orbital dynamics. Once 3I Atlas passes beyond this range, its faint emissions will drop below detection limits. No current telescope will be able to recover what is lost. The comet will become just another dark point, carrying untouched data back into interstellar space. Scientists understand the scale of what's at stake. This is not routine astronomy. This is the only direct sampling of raw material formed around another star system, interacting violently with our sun. Miss a wavelength now, and that chemistry is gone forever. Miss a spike, and an entire formation theory could die with it. What intensifies the urgency is what keeps appearing at the edge of the data. Subtle changes in emission timing, small delays between solar wind impact and X-ray response. These are not errors. They repeat. They hint at internal processes that no solar system comet has ever shown. The countdown tightens. Models are rewritten on the fly. Hypotheses are tested and discarded in hours instead of years. There is no peer review safety net here, only capture or lose. Every scientist involved knows they are watching history with a closing door. As the observation window nears its end, one final anomaly begins to emerge, something incomplete, something unresolved in the interaction data. The signal does not simply fade, it shifts. And that shift suggests the comet may be doing something unexpected as it leaves, something no one planned for. And something that raises a far more dangerous question about what 3I Atlas might reveal next. It becomes clear almost immediately that this is not a repeat event. 3I Atlas is only the third confirmed object ever detected arriving from another star system, but it is already breaking the pattern scientists thought they understood. Its X-ray emissions are not weak or diffuse like expected comet activity. They are intense, layered, and sharply structured, suggesting an organized interaction rather than random outgassing. Researchers notice that the energy output rises faster than models predict as the comet encounters the solar wind. This efficiency is alarming. The comet is converting solar particle collisions into X-rays with a precision never recorded in the previous interstellar visitors. When scientists place the data side by side with earlier objects, the mismatch is undeniable. The chemical fingerprints do not align. The interaction zones behave differently. The plasma structures are unfamiliar. This forces a troubling realization. Interstellar comets are not a single class of objects. They are not variations of the same thing. They may be fundamentally different bodies forged under radically separate stellar conditions. Each one could carry unique chemistry, density, internal structure, and reaction behavior never seen in solar system material. That means every new arrival could behave unpredictably when it meets the sun. 3I Atlas may not be an exception. It may be the first clear warning that the galaxy is sending us objects far stranger than assumed. If the third object already defies expectations this much, scientists are left staring at an uncomfortable question. When the next one arrives, and then the 10th or the 20th, will humanity even recognize the danger in time? Or will the real surprise come with what happens next? The alarm does not come from a telescope lens, but from an X-ray spike no one expected to see. As the data stabilizes, scientists realize the rules have changed. Optical telescopes alone are now blind to the most dangerous signals. What matters happens before light, inside energy, charge, and impact. X-ray observatories are quietly reclassified from research tools to early warning systems. They are no longer just watching space. They are monitoring intrusion. Models of comet behavior are immediately rewritten. What once looked like harmless outgassing is now understood as violent interaction. Matter from another star system slamming into the sun's particle field and lighting up with energy. The numbers suggest something unsettling. Future interstellar objects could trigger measurable energy events near the sun, events strong enough to interfere with solar physics, satellites, or particle environments Earth depends on. This raises questions no one is ready to answer. What happens if a larger object arrives? What if its chemistry reacts more aggressively? What if the next one comes closer? 3I Atlas is no longer treated as a rare visitor. It becomes a test case, a warning sample, a prototype of what the galaxy may be sending through our neighborhood far more often than assumed. Quietly, agencies begin preparing response frameworks, not defense plans, but detection chains. Faster alerts, broader wavelength coverage, continuous monitoring of the sun's interaction zone. The realization settles in with disturbing clarity. Interstellar space is not empty, not calm, and not distant. It is active, populated, and crossing into our system more frequently than models predicted. And as scientists lock onto the next potential targets beyond Neptune's orbit, one question hangs unanswered. What will the next X-ray flare reveal when the next object arrives?